The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome to this afternoon session from SmartFasion, the third one from today. And in this session, we're going to be looking at customer churn or customer retention, if you prefer, and how we can use predictive analytics to retain your most valuable customers. My name is Jarlath Quinn. I'm an analytics consultant at SmartFasion. I'm joined online today by my colleague, Rachel Clinton, and Rachel will be making sure everybody's logged in correctly and fielding questions as we're going along. If you haven't joined any of these sessions before, then it's probably worth knowing that we do record the session, so you'll be able to listen to them again afterwards. And there are some slides that we show. We email out a PDF copy to you after the session has ended. If you think that the session is particularly relevant or useful for colleagues, it may be possible for us to arrange a rerun, maybe as a private session, in which case just drop us an email and we'll see if we can make that happen. And with regard to asking questions, all the lines are muted. So we ask you to use the chat facility to contact us and ask questions. And obviously we'll try and answer them as we're going along. But if we run out of time, we'll follow up with you offline afterwards. So if you don't know who SmartFasion are, we are a technology organization. We specialize within predictive analytics and advanced analytics, particularly within the IBM SaaS and open source suite of tools. We are a premium accredited partner to IBM, to SaaS, and to Predictive Solutions. We also are a team made up of about 8 to 10 people. We've about 15 to 25 years of experience working in the advanced predictive analytics area. So I've personally worked for SPSS, IBM, and SaaS over the past 20 years or so. So we've pretty deep experience in a lot of different analytical applications in lots of different sectors, including retail, charity, central, local government, utilities, insurance companies, telcos, and the media. When we start thinking about customer acquisition and customer retention, there are a couple of things that come to mind, a couple of things that are worth pointing out, and that is that acquiring customers is quite expensive. It's not equal with regard to business expense, the acquisition and retention of customers. The acquisition generally tends to be a more expensive process because of a combination of onboarding, maybe even discount offers at the start, and above the line advertising. So it's not unusual for it to cost 6 times as much as actually retaining a customer. Understanding who is most likely to convert to becoming a customer up front is pretty cost effective. So just being able to apply predictive analytics for customer acquisition, given the costs that are normally faced by organizations, can be quite compelling, because obviously by using predictive analytics, you're not going to be targeting everybody. It's going to tell you who you should be focusing your resources upon. However, as is common, 80% of most companies' profits come from about 20% of its customers. A Pareto rule, if you like. These are common sorts of ratios that we get. It's not unusual, of course, that the majority, that a small minority of customers actually contribute the most amount of money to the bottom line of an organization. So understanding who those customers are and understanding what keeps them happy and what the requirements are key to maintaining their loyalty, of course. And a famous study by Bain & Company found that increasing retention rates by relatively small amounts actually had very large effects upon the bottom line of an organization with the profits. So they found that increasing retention rates by 5% can increase profits from 25 to 95%. So the point is that, if you're using analytics to make incremental gains in one business area, they can lead to very compelling return on investments. So, it's worth doing, even if we're dealing with fairly marginal increases in things like retention or decreases in defection. Sometimes it's just simpler. Keeping old customers is sometimes less simpler than finding new customers and retaining them. When we think about predictive analytics, retention of customers is one of the ones that pretty much sits within the core applications of machine learning and predictive analytics. There are generally 3 areas that are used certainly within B2C organizations, or certainly in organizations that have individual people customers, particularly subscriber-based organizations. Organizations have a subscriber model. Acquiring customers, understanding who your best customers are, of course, is very important. Growing your customers, looking at cross-sell and upsell, making sure that you're getting a larger share of their wallet. So knowing what applications and what services and what products to offer them that are relevant to them is kind of important. And Predictive Analytics has a number of procedures that can help with that. In fact, we'll see an example of that and how we can look at using methods that are usually used to enhance cross-sell or upsell opportunities, and how we can use these methods in conjunction with retention efforts to come up with the best strategy to retain a customer. But retention of customers is the third area. It's one of the ones that a lot of predictive analytics organizations go on about. It's usually most predictive analytics tools will have examples of using predictive analytics to retain customers. So understanding what makes your customers leave and what makes them stay, or keeping your customers happy, or taking action to prevent them from leaving, are key applications. And one of the reasons why that is the case is because it's a very hard outcome. So from a modeling standpoint, it's very much a yes/no outcome. Are they still a customer? Yes or no. Have they defected? Yes or no. And that invites a lot of analytical techniques that like to try and predict a hard outcome, a specific outcome, a class that somebody belongs to. So before we get into it, let's just make sure that we're clear on the terminology here. So predictive analytics, when we talk about it, we really think of it as a banner term that comprises a range of different analytical techniques and analytical traditions. And certainly Wikipedia makes that point when you look it up, and it says predictive analytics encompasses a variety of statistical techniques from predictive modeling, machine learning, and data mining that analyze current and historical facts to make predictions about future otherwise known events. So in other words, it's a bunch of techniques from different traditions, from the statistical tradition, from the data mining tradition, from the machine learning tradition. IBM simply make the point that it is the analysis of structured and unstructured information, certainly things like text-based information, unstructured data, video, audio, that type of stuff, is increasingly being deployed to enrich decision-making through predictive analytics and through machine learning. We have found, certainly by utilizing, for example, open-ended text, that it has quite a marked effect upon the accuracy of many predictive models, but particularly within the realm of customer retention applications. So if we've got things like email or call center data from people, or complaints data from people, it's really powerful to try and combine that information with the structured data that we have, the numerical data, to help us enrich the models and make better decisions with regard to identifying customers who are likely to defect or likely to cancel a contract or a subscription or go elsewhere. It's perhaps easier, rather than trying to come up with a snappy single definition of predictive analytics, to just bullet point it and talk about what it is and what it isn't. So the first thing, the point that we make, is that it is quite distinct and different from things like management information, BI, business intelligence type reporting, dashboard solutions that one would get, because it's trying to do something different. It's not simply about monitoring information or even necessarily driving insight all the time. The second thing is, it's not always, ironically, about prediction. There's a lot of predictive analytics applications that aren't predictive in nature, such as anomaly detection, segmentation work, where we group similar customers together or similar events together, even similar stores or businesses together. And that's not necessarily a predictive model. But predictive analytics, one of the things that very, very much makes it different from BI and MI is it produces new data that did not exist. And these new data take the form of columns of information, usually in the form of estimates, probabilities, forecasts, recommendations, propensity scores, classifications, or likelihood values. So this is one of the things that makes it very specific and different from MI or BI. Its goal is to produce new data that enables us to make a smarter decision. And obviously, in the case of retention and in the case of retaining your best models, your best customer, that these are going to be comprised of models that generate new data that show, for example, the likelihood, the probability, or the propensity of the customer to remain a customer, to defect, to leave. So that's really the acid test for our application: is can we generate that outcome, and can we make a better decision with it, and is that outcome useful to us, is it accurate, etc., etc. So we take those results and we tend to incorporate them with operational insight systems. So operational systems might be, for example, if I have a column of numbers that's attached to, let's say, 20,000 customers, and the column of numbers indicates their likelihood to, I don't know, defect or renew a contract at the next time that their contract comes up or the subscription comes up for renewal. What can I do with that? Well, I can send it out to a operational system such as a campaign management system. So a campaign management system might be used to target customers who have a high likelihood of churning, and therefore that's where that decision point or that insight or that new data is integrated with the decision point. Alternatively, it could be surfaced to them when they connect through a website. So it could be generating an offer or a text message or an email. And alternatively, it can also be incorporated within the existing insight system. So if you've got visualization tools, if you've got Tableau, if you've got business objects in the form of Cognos for BI tools, why not take these new numbers, these propensity to defect numbers, for example, and incorporate them into those tools so that that insight is surfaced and presented to decision makers who regularly make use of that. So this type of approach, where we're producing these new numbers that show us the likelihood of a customer to remain a customer or to defect, can be used to underpin a more generic loyalty analytics application. So let's be clear how predictive analytics actually works and how modeling works. Okay, so just to be clear, predictive analytics is using historical data from many people or incidents. So we're talking about things that people have done, transactions they've made, or information about the people themselves, their historical history in terms of their age, their gender, their average spend, their maximum minimum spend, their tenure as a customer, what product categories they have shopped in, what region they live in, etc. And there's some sort of known outcome or result. Usually, they responded to an offer, they upgraded, they defaulted on a payment, they recommended it to a friend, they donated, or in this case, they cancelled or renewed a contract or a business contract or a subscription or something, or their business with an existing supplier. So that would be our key outcome. Now, may well be that in some situations, particularly as retailers, you don't actually know if that customer has definitely defected. I mean, it's not like you're on a contract to go to a supermarket. So in those cases, a lot of businesses will just pick an arbitrary time point, such as if this person hasn't shopped with us for 6 weeks or something like that, we can assume that they have defaulted or that they have defected to another location. So they pick an arbitrary time point. Either way, we've got to define, we have to have a definition of the outcome. We've got to say this person is still a customer, this person is not still a customer. But we do this in order to build a reusable model. And it's reusable because we want to be able to apply the model to new data to generate these outcomes, to generate these recommendations, to generate these probability values. So that model itself is simply just a pattern or a formula. It really, at this stage, it really doesn't matter what it is, whether it's a machine learning algorithm that's generated, whether it's a traditional statistical algorithm. Point is, it's something that we can examine and we can test and we can see how accurate it is. And we tend to treat it as a physical object, as a thing that we can use and that has a certain lifetime and a certain utility. And after it's past its lifetime, it tends to be archived away. So we treat it with the same degree of respect, if you like, that we treat the data that it's built on with. So we don't just necessarily just delete data when we're not using it anymore. We tend to archive it. Okay, at the heart of loyalty analytics is this idea of the model. It means we can take new data from individuals' incidents, and that data, of course, based on the same information: age, gender, average spend, sentiment, time since last visit to the website, for example, the number of contacts, emails, anything that they've said online, any sort of information we have about the customer, really. And using a model based on the same information, we generate these new values, probability values, these likelihood scores and estimates, these predictions. And of course, the predictions themselves don't have to be related to churn and retention. They could be related to predicting lifetime value, or people's likelihood to recommend you to a friend, or their net promoter score, or probability recommended, or in this case, I guess, percentage chance or probability of them cancelling or defecting or going elsewhere. Okay. So when we think about how we use that model, if we were doing an outbound campaign, a regular campaign, and trying to retain customers that we think are in danger of defecting, the model itself isn't going to exist in a vacuum. It does have to take account of the fact that there are only certain people you're going to send it to. The certain people who are deceased, who say do not mail, who are no longer customers, and certain people who are not eligible for the campaign. They're not profitable, so there's no point asking them to try and target them, or they haven't been customers long enough to cancel. They're 10 years less than 3 months, leaving you with a pool of people against which there is a possibility that they may defect. Yeah? So the model simply comes along and says, okay, I have quantified the risk of defection, and I have identified those of the highest degree of likelihood to defect, to churn, if you like. That's effectively what the model is doing. We need to see it within the wider context of the selections that we make within our customer data anyway. So it's basically another filter that we're applying, because obviously we don't want to treat everybody as if they're going to defect. We just want to identify those people who truly have a high likelihood of defecting, and then to do something smart to try and retain them. So what that smart thing is that we try to retain them is a moot point. We really have to think about the decisions that we make and how we're going to interact with the customer in order to mitigate the risk of them defecting. So it may be that, for example, we're sending a letter out, or a physical voucher, or some sort of thing that goes through the post to them. It may be that we're sending an email out to them, so it's an electronic. It may be that's somebody else's job. That actually our job is to score the data and hand it over to the customer defection or the customer churn team or retention team, in which case we're scoring a database at 2 o'clock in the morning. So our main goal there is to try and get those scores out, those likelihood of defection scores out in such a way that it doesn't hurt the rest of the environment. Or it may be that we are surfacing offers to them on a website when they come and interact with us. Or it may be that we're sending the scores out to a BI or MI tool so that we can see the risk of defection broken down by various standard KPIs or measures, demographics, regional, product type, segment. Or it may be that we're actually going to fire models in real time based upon interactions that the customers are making with us. So, that interaction could be over the web. You see these little pop-ups where people are typing in text, and you can mine the text in real time and say, estimate whether or not that person has a high likelihood of defecting. Or it can be through a conversation that the individual is happening with a support representative, and as the support representative is taking note and typing in information and answering the questions, a model indicates their likelihood to remain a customer and gives that person a recommendation to the support rep as to what to do to retain them. So if you think about the sorts of the two models there of deployment of what we're doing, the scores, one is proactive and the other is dynamic. Okay, so the proactive one is the outbound campaign. That's where we're not waiting for the customer to contact us. We're actually sending pieces out to people in the form of email or physical mail, and we're taking the opportunity to interact with them. And the advantages of that are that we can integrate them with existing campaigns. We can set the decision agenda. We can plan it in advance and say how many we're going to send out. And it's less costly and simpler than dynamic, but it's also less timely and less accurate. You know, very often by the time you've done this, the person has pretty much made up their mind to defect, and that's a real problem. You know, whereas you're not actually predicting their defection, you're merely detecting it within the data, and by the time an offer goes out to them, it's too late. Whereas at least with dynamic, we're gathering data in real time, and we're gathering new data in real time, data that we don't know about the person, because we can interact with them and ask them for information. So it gives us the opportunity to gather information. If we don't know their date of birth, if we don't know their where they live, for example, we can actually ask for that information. And we have the opportunity there to optimize the offer or action. So we can say, well, there's lots of different actions we can take at this point, but given the conversation and the interaction we're having with the customer, you know, we can optimize that offer or action. And the outcome can be captured immediately, because they can say, yes, I accept that, or no, I'm not interested. So we know what the result is immediately. Whereas if we're doing a proactive outbound, we've got to kind of wait around to see what happens, to see if they respond to it and whether or not they renew or not. However, dynamic or inbound real-time scoring is more complicated and requires a slightly greater investment than proactive approaches. So there are some pros and cons here. There are pretty important pros and cons, just with regard to how we make these decisions that the model is suggesting to us based upon the probabilities. Even when the application isn't a predictive model, however, we can still use historical data to better understand our customers, to find, for example, strong correlators or drivers of behavior. So just from an insight standpoint, to carry out text mining and analyze changing sentiment over time, how customers are talking about us over time, how our brand is being perceived by monitoring Twitter feeds and social media, and seeing how people are reacting to things in the press, for example, or to adverts that are being aired on television, and seeing what they're saying about that. Or we can develop a segmentation strategy that is data-driven, so one that allows us to group similar customers together and create our own segments, but not based upon us enforcing a top-down segmentation scheme on the customer base, but rather using the data that we have about the customers to come up with segments. In other words, to go beyond things like recency, frequency, and monetary, if you've heard of that way of segmenting customers, to incorporate who they are, demographics, what sort of product or service categories they shop in or they use, how they interact with us in terms of the web, the call center, the payment methods, or their history in terms of their tenure, their customer journey, etc. So we come up with much more complex and richer ways to characterize and classify and segment our customers. So if you think about how your own customers are characterized, is it based upon simply the services and products that they make use of? Is it a top-down segment that's being enforced on it? Or is it actually data-driven, where you've looked at the pattern of behavior and asked the data effectively to classify or categorize the customers into different groups using techniques such as cluster analysis, which groups similar customers together? And you can imagine how this is quite useful when we're trying to make a decision about customers who are likely to defect. So, for example, if we know that they're likely to defect and we know what cluster group they belong to, then it may help us calibrate the sort of offer that we should make to them, or the interaction that we should make with them, based upon the type of customer they are, rather than simply treating everybody in the same way. So if we think about something like another example here, where we look at something like a next best action, if we look at something like a person like Donna here, so she's got her credit card details have expired and she's not updated them. On average, she spends about £36. She belongs to a particular cluster segment, such as Business Bedrock. She usually spends once every 6 weeks. Her estimated net promoter score is 7, her likelihood to recommend this to a friend or colleague, 7. And the retention model says her probability of defection is quite high at 48%. You know, there are possible things we can do. We can say, well, actually, we're not going to do anything. You know, just leave it alone. Or we say, well, actually, she's not eligible for the free upgrade, the free delivery upgrade that we're going to offer. Or we offer a discount based on her probability and lifetime value. So we say she's got a certain lifetime value and a 48% chance of defection. Why don't we multiply the chance of defection by the lifetime value so that we can calibrate the offer we make to her? Or or offer the discount based on the next best offer product category. In other words, we could treat her as if she wasn't going to defect and say, well, what is the next best offer to make to her based upon a completely separate algorithm, and then say, well, if this is the sort of product category or service she is likely to make next use of, maybe we should offer her something based on that product or service category, or predict which one of our 4 standard retention offers is most likely to work. That would require us to have historical data where we have tried out different retention offers and discovered which ones work best with what type of customers. So we may be using an algorithm there to figure out which one is most appropriate for her. So in all of these cases, we're trying to think that given the fact that she has a high likelihood of defection, what is the right thing to do? So simply predicting likelihood of defect is sometimes quite easy, but figuring out what to do to mitigate the risk of it is sometimes harder. Other things we can do is can we actually define or detect churn? Can we say when somebody has churned when they've left? Can we predict churn or defection likelihood earlier? It's pretty easy to predict, for example, in a lot of subscriber-based applications, whether or not somebody is likely to renew their subscription 1 month before their subscription ends, but it's harder to do it 6 months before the subscription ends. And really, you want to be able to do it earlier, before the customer makes up their mind, before the subscriber makes up their mind. So sometimes it's best to try and predict not necessarily the churn or defection likelihood, but to predict on a regular basis their level of satisfaction or their likelihood to recommend you, and use that as an early warning system to intervene rather than simply trying to predict their likelihood of defection or churn closer to the time when that is likely to happen, such as in a subscription where a contract is likely to expire on a certain date. Can you optimize your retention actions in the way that we've talked about earlier, even roughly? Most importantly, can we quantify the gain? Can we say how much this retention model actually made us? Now, one of the ways in which we can do that, of course, is we can have a controlled test. We can actually just have a business as usual approach and just leave a whole cell of people in a certain group and say, okay, well, whatever we do normally, we'll just do that on a normal basis and monitor the retention rate on that, or the defection rate, if you like, compared to a group where we're trying to retain them based upon a model score, and then look at the gain that we've made using one method over the other, so that we can then say, well, this is the value of each prediction. This is how much it actually saves us, if it saves us anything at all. Okay, let's look at an example. We're going to skip out now to an IBM product here. So we're going to look at the product here. This is called the IBM SPSS Modeler product, and this is a data mining or predictive analytics workbench, if you like. We can use it to help us build these retention offers or to identify people who are likely to churn, if you like. So to do that, I've got a very simple example here. This is called B2B retention. So look at this. So I want you to focus really on this part of the screen where we've got some data here which are emerging from an IT products and service vendor. And this data is being merged together. We've got transactional data. So we've got, if I show you the top 10 rows within this table, within this database, you can see this is simply a marker as to whether or not these people have made a purchase within these different product group areas: audiovisual, networking, service hardware, peripherals, etc., and whether or not they are still a current customer. And then we have their transactional history, so some data from the transactional history, such as the total revenue, their first trade, their last trade, revenue that we've made per sale, whether or not they have a support contract, and the sector that they belong to. If we merge these data sets together using a merge node here, of course we get now a data set of 15 fields. It's a very small data set. Normally we'd have much more than that. But if we want to see an overview of that merged data set, we can see an overview here. And what you notice is that the overview of all the different values and variables that we've got in here, they've been colored green and yellow to indicate their current status, whether or not they're still a current customer or not. So 0 means no, they're not a current customer. Yellow means yes, they are a current customer. So 0 are the people who have churned, if you like. And we've got a lot of data here, such as their mean revenue. This is a histogram, but it's very, very narrow. But we've got other things here like sector. You can see how the sector breaks down by their current customers. And it generally just gives us an overview of the data. So we've got about 6,192 valid cases. We've got some missing data in here in some of the fields, but most of them are populated. And we're now left with this situation where, you know, having really manipulated the data and cleaned it and merged it and really gone through what we call the data preparation part of our CRISP-DM methodology, of which I'll talk about in more detail later. We're ready to do some modeling. We're ready to use the historical data to try to predict an outcome for us. So if we want to predict this outcome, we have a lot of different algorithms that we can use. There's a lot of different algorithms here which will help us predict this outcome. So which one do we go for? I mean, we could use this one. 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 This one. This one. There's a lot of different algorithms. Which one's the correct one to use? Well, fortunately, we've also got an algorithm here called the auto classifier, which will attempt to run all of those algorithms and many more and make them compete against each other to predict this outcome with the highest degree of accuracy. So this is shown here. So I've just connected it up. So if I just connect up my auto classifier, what you notice is when I connect it to the data, it says current customer, and that's because I have put this little node in here to indicate what is my target field, what is the thing I'm trying to predict, and it's called current customer. So that's the thing it's trying to predict. Are you still a current customer, yes or no? Have you defected, yes or no? And if I run that procedure, I can let it run, it's going to build many different models. So we can see it building these models in the background here. So it's going to build up to 10 models, and it's going to retain the best top 3, I think I've asked for the top 3 models, which algorithms work best here. So we'll just wait for it to come. It takes about a minute for it to do it. And having done so, we can look inside the nugget that it produces. So it produces a physical nugget, if you like, which here it is here, this gold nugget, because it's sort of a data mining reference. We've mined the data, we've got this nugget out. And then when I look inside this represents the actual model itself. We can see that the model here is made up of something called a C5 tree, a CART tree, CNR tree, and a shade tree. So it's chosen these methods for us, each one of these methods overall. So saying it's saying that this one is the best one. It's 78% accurate. This one's 77% accurate. And you can see how accurate it is. You can actually physically see how accurate it is because it's telling me in this little table here that, you know, this little chart, that this is how many times it has correctly predicted a 1, that's the greens, to be a 1. And the blue in the 1 column here are people who it has predicted to not be a current customer, when in fact they are. Here, conversely, the green in the blue group are people it has predicted to be to be a current customer, a green group, when they're not. So this is basically this group, these 2 little values here, these 2 little parts of the chart. The green here and the blue here represent the error in the model. Because remember, the model here, as we see in it, it's 78% accurate. So it means it's about 21% inaccuracy. That's where the 21% inaccuracy is. And that's a good model just based upon that information, because, you know, any model which is 100% accurate is extremely, well, it's almost certainly incorrect. It's probably using a self-fulfilling prophecy. If we want to see inside the algorithm itself, inside the model itself, I can double click on the nugget that makes up that specific algorithm, the C5 algorithm, and I can see it as a series of rules. So it's saying, okay, you know, if they have networking and the level of contact with us has been less than 11, then we can say that they're probably going to be they're probably going to be a churner, a 0. Yeah, so saying this, you know, and we're saying there are 2,000 people in that group there. 83% of them belong to this 0 group. Okay, so these are all rules. So the model here is built on a series of rules, and we can unfold all of these rules. It's finding all of these rules Alternatively, we can see it as a tree, a decision tree, where we have 6,000 cases at the top here, and it says basically 50% of them are no longer customers, 49% are. It says basically here, it says if they've bought networking at some point in the past, maybe they've stopped selling this, but they're saying that basically the networking, they all belong to the current customer group. If they if they haven't bought networking, they all belong to the current customer group. If they have bought networking, then 60% of them have churned. If the level of contact in networking is less than 11, then 83% of them churned. If it's greater than 11, then that drops to 45%, so it's an exception to the rule. Then it starts looking at total revenue and says, okay, but if the total revenue is less than £31.9, then 86% of them have churned, and we've even got minus revenue here. We've got refunds, so it's going in the very small subgroups. We can see that this whole model is actually what's called a decision tree, where people go into subgroup of subgroup of subgroup, and it's building a profile, a complicated profile, it has to be said, of the differences between the churners and the non-churners, the greens and the yellows. You get a similar thing if you look inside these other models here, such as a shade model here. It's a very similar thing, but it's slightly different algorithm. In fact, this will produce predictions for us, and it will be using all three of these models. You can see it says 3, use. So when I click preview across the top here, it produces this new field. I said at the start that predictive analytics applications produce new fields. And here it is with its prediction. So you can see it's actually got these ones wrong. This one's correct. This one's correct. This one's correct. This one's wrong. These ones are correct. And it's telling me the level of confidence it has for each of these predictions. Those predictions are generated by combining the predictions from all three models. That's why we have use. If we didn't want to use, say, that one, we'd just switch it off and it wouldn't go into the prediction. So it's basically as if they are voters on a panel and they're voting, literally something called Ensemble Voting, to see if to make an evaluation as to whether or not the person is likely to be a current customer or not. And there's a little chart here, a little graph that shows us based upon all three models what are the most important fields. Well, when you're based on all three models, you get quite even fields. What happens if I go back here and I say, do you know what? I don't really trust this model. I don't trust this model because I've based it on all of the data. I haven't really tried it out or tested it against data which was unseen. So I can do that. I can actually go back to, this is a standard approach for building model. We can do something called partitioning the data. And partitioning the data means that simply that we've created a marker in the data set called the partition field, which randomly assigns cases to one of two groups, training or testing. Anything in the training group, when I rebuild the model, will be used to generate the final algorithm. The algorithm will use that to build the model. The testing group, those cases that are in the testing group, will not be used in the building of the model. We can hold them back. It's literally called a holdback sample. We can hold them out or hold them back in order to test how well the model can predict these unseen cases, these cases that wasn't included in the model. So if I run that again, I'm actually going to go into it a little bit more, and I'm actually going to ask it to switch on a few more models, because we've got a few more modeling techniques here. So I'll switch that one off, and I'll try this one. We've got Bayesian network. I'll switch that one off. It's not so good. That one there. That's okay. Let's try this one. Decision tree. We'll try two different types here. I'm just going to play around with it a little bit and produce some other trees for me. And hit run. Okay, let's try it again. But this time, when the model's built, it will only be built on the cases that fall within the training group. And it will select the best model based upon the performance in the testing groups. When I look inside here, now again I have a C5, two C5 trees and a cart tree, so two different versions of it. And you can see that this is your performance in the testing set. If I click to the training set, you can see that they do a little bit better in the training set. The testing set is how well it did on the unseen data, and it's 76% accurate in the unseen data. On the training data, it was 79% accurate. So it still produces predictions. It gives us an idea of how well the model is performing. And we have a few other little techniques here to help us evaluate the model performance. So here, if I show you how the model is performing and run this, what's called this gains chart here. The gains chart shows me how the model performs for the training group and for the testing group. And this one, this is trying to predict current customers. So how good a job it does at predicting current customers. I can get it to look at the non-current customers, but you get the idea. It's going to look quite similar because it's similar proportions. If the model was random, it would look like this red line, okay, where we'd have to sample 50% of the data to find 50% of the current customers, because we're just using a random approach. If it was a perfect model, it would look like this blue line, where we could get a gain. If you look at the gain number there, 100% from 51% of the data. It means that you could find 100% of the current customers, accurately predict 100% of the current customers to be current customers from 51% of the data, because 51% of the data are current customers. And the green line represents the model, or the combined models that we've put in here. So these three models are all combined together, and it says, well, actually, I can get you 75% of the current customers from 50% of the data. So it's telling me how much better it is than random, but how much worse it is than perfect. It's a nice way for us to select that. Alternatively, we can drill down into the actual numbers themselves and say, well, how many do you physically find? We're looking at the training and testing group here. Here's the training classification. Here's the testing classification. The rows, the 0 and 1 in the rows here show the actual values. The 0 and 1 in the columns show the predicted values. So this is saying that it predicted just under 1,300 cases to be zeros when they indeed were zeros. But here it predicted 271 cases to be zeros, to no longer be customers. To be current customers when in fact they weren't current customers. And conversely, here it has predicted 477 to be zeros, i.e. to churn, when in fact they were current customers. This is the error in the model. That's the sort of the 23.7% that's wrong. So as we know, these models here produce numbers for us. They produce predictions for us, and we can use these models. So I can pick out one of those algorithms. If I like one of those algorithms, I can pick them out. Let me just see if I can find the right one here. Okay, here we go. I've picked out a C5 algorithm here. And here is the prediction it's making. So it creates this prediction called current prediction, so current customers. So it's predicting quite a lot here in this group here to no longer be current customers. So here it says include everybody. It's a 0. That's I'm filtering them out. I'm filtering likely defectives, because of course I'm only interested in this group. And if I want to do that, I just have to click on this and go generate a filter node for me, a select node. And as you can see there, if I look inside this, it's doing the same thing. So it's just basically include everybody. It's a 0. So that means I'm just looking at the people who are zeros. Remember that we're basing this upon, if I just show the data that we're basing this on, we're basing this on data where we don't have a variable that indicates whether or not they are churners or not, because we don't know if they've churned or not. This is live data. These are all current customers. We are using our model to score them, as we call it, to produce predictions. And I'm going to rename the prediction field to the actual probability of prediction to risk of defection. I'm going to drop all of the other fields because I don't need them. And then if I show you what I'm going to end up with, I'm going to end up with a risk of defection. Here we go. Some of these are 0.58, some of these 83%, 67% against the ID numbers. And I can then send that out to a database, and it scores the database. Now, in fact, it actually turns everything into SQL. It turns the entire stream into SQL so that the data doesn't leave the database. It turns the model into SQL. The model that is being turned into SQL is basically the series of rules that's produced. Very simple model here. So that's how we would score the data, and we'd end up with, we then target those customers. We target them and say, okay, these are the ones we think are going to leave. we're sending them to a decision point, an operational system like a campaign management system, or to a database. And we're saying, okay, these are the people who are likely to defect and likely to not. What do you want to do? You know, what do you want to do to try and retain them? So it might be that you multiply the probability by their lifetime value, by their profitability, and say, okay, that then I'll prioritize the people I'm going to call or contact, or proactively reach out to, or offer a discount to, or whatever, based upon their profitability and their likelihood to defect, the ratio of one to the next. Or alternatively, you could try and predict what the right thing to do is. So to give you an example of how that might work, you could predict what the right thing to do is. Here I have some customers where we've already calculated their likelihood to churn. So this is the churn risk model here. So you can see it goes up to a maximum of about 0.6. That's about that's been 60% likelihood. Most of them don't have a very high likelihood. And we've also got a lot of products that they've purchased in the background. So we've got these products that they've purchased. This is their product history, and I can see what products that they have purchased, and I can see the relationships. So if I just filter out and show you the strongest relationships, here we have very strong relationship here between purchases of drapery and lighting and furniture, and bathroom and furniture. So there's kind of this overlapping relationship here between these different product groups as to what they've purchased in the past. Maybe I could use these relationships to help predict what I should be offering them to retain them. So that's a different type of modeling. This is called an association model. And if I run an association model here, what it does is it basically takes that web plot that you saw earlier on and it turns it into a model where it predicts what you should be offering them. This is called the consequence. It says, well, if they've got these things, you should offer them something from lighting. There are 10% of people have bought these products, have shopped in these areas, and of those 10%, 98% of them have bought something in lighting. So you could use these recommendations. So you can think of them as next best action recommendations, which are being pushed out as new fields, new recommendation numbers. See, this person here has an 86% chance of churning, and it's recommending that, if they were still a current customer, they're going to remain a current customer, the next thing that you should offer them would be furniture. Maybe we should use that to help us calibrate the offer that we're going to make them to retain them, a discount voucher. So we would attain the twin goal of retaining them, of offering them something that was pertinent to their sales pattern, and getting them potentially to make another purchase within the store itself. And we would score the data in exactly the same way. We would have this B2B scoring. So we'd have this home goods retention scoring. So if I open that up, we've got a little stream here, and we'd score the data. It produces this nugget for us. And we could combine as we say, we could combine this likelihood, this recommendation, with the probability of defection. So we've got current risk, and we could send it out and say, okay, this is the thing we should do. These are the offers we should make. And if we don't like offering them furniture, we could say, well, actually offer them something in bathroom, because that's also a high likelihood. And if they don't like that, offer them something in garden or outdoor. So you could offer them a voucher for all three of these products, customized to them, if you like, and say, you're going to be offered 25% off. This is an exclusive offer to you and to our most valuable customers, blah, blah, blah. So that's kind of a little bit of food for thought there, but with regard to, good practice with regard to identifying customers, developing a model to identify customers with a high likelihood of defection, selecting a model, such as using an auto classifier to help us find what is the best model of the top 3 modeling techniques and types. How we can evaluate the performance of that model using a test or training group. How we can send the results, the probabilities of that model out to another system for recommendation. And how we can calibrate an offer to be used in conjunction with people who have a high likelihood of churning or defecting. So that they're not just getting the same offer for everybody. We're actually trying to take account of their sales pattern and their sales history. Okay, Some words of advice we would add at this stage, just general advice we would give to people. When we think about our clients and our customers and the people who are doing this, and the ones which are most successful, the ones who are most successful tend to utilize an existing methodology for developing these applications. And it turns out there is a methodology called the CRISP-DM methodology. It's actually built into the modeler software, which really offers a roadmap on how to develop an application, how to plan it out properly. And it has its own website, which we maintain, called CRISPDM.eu. CRISPDM, of course, standing for Cross-Industry Standard Process for Data Mining. And it really is a fairly meticulous, well-documented approach to developing predictive analytics, data science type projects, if you like. It keeps people on the straight and narrow. Very often we have found that when projects have not been successful, we've been able to trace it back to a problem that you can identify within CRISP-DM, something that wasn't done, which should have been a step that should have been correctly monitored and investigated and really dealt with within the CRISP-DM process. The other thing that they do is they tend to exploit a wider data landscape than other individuals might. So they tend to not just look at things like transaction history and transactional data and descriptive data, demographics, geodemographics. They tend to look a little bit further. They tend to look for interaction data, whether that be in the form of when people have contacted them, how often they've contacted them, how they've interacted with them as customers, have they ever complained, do they visit the website, can you detect when they visit the website, have they sent emails, that type of stuff. And try to use that data to really give them a higher degree of accuracy and a deeper and richer model. And even things like attitudinal data, social media data, if they can use that and utilize that, then they will do so. Some of this additional data may be unstructured in nature, and we can utilize that within the model application. We can mine the text to create flags and indicators that help us enrich the model. And we can also integrate it with various systems. It doesn't have to just be IBM SPSS. It might be sending them out to other systems. Could be using SAS instead here to generate these predictions. So there's lots of different tools that are available, but using the right tool for the problem is kind of important. If you're trying to achieve these through tools which don't allow you to be productive, maybe you're using open source tools which are very complex, which aren't maintained, which although they're cheap but they're not maintained, or you're trying to do it through tools which really aren't designed to do it, such as Excel or spreadsheets or BI platforms or even standard stats tools rather than data mining tools, then you will struggle. And I think that it's worth, given the opportunity value for most businesses of retaining their customers, it's worth using the right sort of platform, the right technology to do that, because it pays dividends. Integrating the results with existing systems. You may have marketing operations management systems. You may have BI tools. You may have web platforms that you want to use the recommendations so that people can have offers or interactions flagged in real time when they interact with us. So thinking really about where the results are going to go and how you're going to integrate them. It isn't actually that difficult to integrate these scores, because they will punch out data in lots of different formats that most systems will be able to read and incorporate. And there's no shortage certainly within the IBM website of other businesses that have done this, that have that have increased their retention using predictive analytics. And you can look these up. We can go over Aircom. Aircom was able to identify the most effective ways to improve customer experience by reducing churn on key customer journeys by around 6%. Or C-Spire Wireless, where they improved the effectiveness of retention campaigns by 50%, and indeed boost their cross-selling and upselling rates and selling accessories by 270%. So there's lots and lots of stories out there that you can look around, and we've got some of our own. Common misunderstandings people have, the idea that you need to have a PhD or you're going to get revolutionary results overnight. It's usually an incremental process. You certainly don't need a PhD to do this, but we do find that people who are data literate, who have mucked about with Excel, who have used BI tools, and who are very business focused and have a vision of how they want their retention strategy to work. These are the people that we kind of look for, and these are the people we often find make the best use of these types of tools. You also shouldn't focus too much on the accuracy of the model. The more accurate the model, the better. Generally speaking, very accurate models are, of course, very, very good. But very often, accurate models are unstable models, or they're difficult to understand, or they're difficult to translate or deploy, or to make sense of. So sometimes you will choose a model which is slightly less accurate than your best model because it's simpler, because it makes sense, because you can turn it into SQL, because it's easy to, it scores the data quickly or whatever. And lastly, a lot of people think, yeah, we'll do this when we have our nice, clean, single customer view of our warehouse, which of course means that they generally never get round to doing it because most businesses never do end up with a nice, clean, single view customer warehouse. So we advise you to get kind of stuck in with the existing data. Other advice to get started: build internal credibility. Think about where you get the biggest impact for least effort. Consider adopting and looking up ChrisDM. Don't get hung up on modeling techniques. Rather focus on the business understanding phase of the ChrisDM, i.e. why you're doing this, how good the model has to be, and the deployment, how you're going to monitor it, how you're going to make decisions of it. Consider the full data landscape, not just transactional data and demographic data. Consider who's impacted, what other roles are impacted. Very often deployment of this type of tool, these types of capabilities, mean that somebody's job has to change. Yeah? So you need to think about that and think about, are you going to hit barriers, or have you got everybody on board that needs to that you need to make this work? Consider integration with other BI tools. If you've already got BI tools, why not have the scores from a model, a likelihood to remain a customer, retention risk scores, integrated into your existing BI or MI platforms, whether even if that is just Excel. And really focus on how you know it's worked. Focus on measuring the benefit. Think about training and testing. Think about having a holdout group, a control test, so that you can say that this model increased our retention rate by X amount, and that was worth X amount. So you can actually say this is what the model's worth. Otherwise, it's kind of difficult to argue a case for it. With regard to working with us, well, you can buy your analytical software directly from us with discounts. And you can buy it directly online. We can also assist with the selection of tools, pilot projects, implementation, and support, generally around a range of different analytical tools. We offer training and consulting services in the form of classroom training, side-by-side training support, even identification and recruitment of analytical skills into your organization. And we offer generally no strings attached device technical support services around SPSS, SAS, and predictive solutions. I do hope you find that useful. We will have a number of other webinars coming up in the new year. If you want to check those out on our website, you can do so, and you can subscribe to them. You can also view recordings of previous webinars if you find that those are useful. In the meantime, thanks very much for logging in, and we hope you log in again at some point in the future.